everybody. My name is Pariksha Vij and I am pursuing Masters from Thapa University in CSE. And my topic of discussion is effect of rumor propagation on the market dynamics using cellular automata. In stock market, the participants interact with each other before making any investment decision. There are various factors that affect the decision of the market participant. Interaction among the market participants acts as a channel to propagate any sort of news or rumor. The mechanism followed by the market participants is word of mouth communication, that is, one person interacts with another and passes on the information it has to the other one. This is how the information is spread in the entire stock market. Now, the motivation behind using cellular automata for this analysis is that it has been observed that using simple transition rules, cellular automata often leads to complex behavior and patterns. Basically, the cellular automata is a grid of cells in which each cell is a finite automata and can have a finite set of states. The neighborhood in cellular automata can be either von Neumann or Moore neighborhood. Von Neumann neighborhood approach is defined by the four directions of the compass, that is north, south, east and west, and C being the center, whereas Moore neighborhood approach is defined by 8 directions on the compass. So a local transition rule is defined to update the state of the cell C. The local transition rule is the function of the present state of the cell C, its previous state, and the previous state of the neighboring cells, that are the 8 cells which are neighboring the cell C, or the 4, depending upon which neighborhood we are considering. So many researchers propose different models to analyze the dynamics of the stock market. The 3 basic concepts of market analysis are rational investor hypothesis, efficient market hypothesis, and random walk of yield rate. According to rational investor hypothesis, it has not been proved yet that the market is composed of only rational investors. Random walk of yield rate defines that without assuming additional risk, it is impossible to outperform the market. It believes that the stocks take an unpredictable random path. Now coming on to efficient market hypothesis, it states that the share prices incorporate and reflect all the relevant information about the stocks, hence it is impossible to outperform the market. The 3 levels at which market might actually be efficient are described as strong form, semi-strong form and weak form. In semi-strong form of EMH, if all the relevant information about the stock value is quickly and precisely reflected, it believes that the market can become efficient. Whereas in semi-strong form of EMH, if all the relevant publicly available information is reflected in the value of the stock, the market can become efficient. In the weak form of EMH, the concept is confined to just one subset of the public information, namely historic information about the price of the stocks being traded. Santa Fe Artificial Stock Market (SFM). This is the original version of artificial stock market. It was a kind of multi-agent system which stimulates the behavior of heterogeneous market participants. According to Santa Fe, the investment process of the market can be divided into following, that is predicting and decision. In predicting step, the market participant considers the information that it receives from the different sources, that may be public or private, or from within the market or from outside the market. So it basically collects the information, whereas in the next step, decision process, it reacts to the information that it was made available in the prediction step. Next is classical cellular automata based financial market. To model the non-public influence in the stock market analysis, cellular automata came into light. The 2 most frequently appearing behavior in the developing financial markets is herd affection and group psychology. The influence of herd affection is modeled using cellular automata in which each cell is a market participant And the cellular automata is the stock market. Each cell can have one of the three states, that is buy, sell or hold, with the values -1, 1 or 0. And the cell decides its state by imitating the behavior which is followed by the majority of its neighbors, hence the name herd affection. So problem statement is that rumors were till now almost absent from the economic theory, because economic theory is somehow believed to be rational and rumors were considered to be illogical. And objectives that we want to meet are to analyze the impact of rumors spread through word of mouth communication on the stock market with and without applying constraints on the propagation transfer mechanism. Second is to apply the rumor parameter in the leaning function, which I will be describing later on, to observe its effect in the stock market. So this is the work done. Implementation is as defined. Cellular automata, as I've already explained, is a grid of cells representing the stock market, and every cell represents a market participant. Each cell in a cellular automata is a finite automata in itself. The state of any market participant at time t can be any of the three: buy, sell or hold. Time is considered to be discrete. Buyers are represented using the value -1, sellers with value 1 and holders with value 0. A market participant P can directly communicate with its adjacent neighbors, that is as shown in the figure. So this is a figure where P can interact with its 8 neighbors, P1 to P8, which is more neighborhood approach for market participant P. So this is the approach that we will be using for our model. So I've actually implemented on a grid of 50 by 50, but to demonstrate the results I've used grid of 3 by 3, that is 9 market participants. So this is basically this is showing a market. Negative -1 is for the buyer, 1 is for the seller and 0 is for the holder, as explained earlier. So this is the market, and we'll count the number of market participants depicting different behaviors, as this shows that initial buyers were 4, number of -1, initial sellers are 3, that is number of +1, and initial holders are 2, that is 0. So for every single market participant we are to consider the 8 adjacent neighbors. Now the element that is present, that the market participant present at 1 has only 3 neighbors. So to make sure that it has 8 neighbors, we will build a virtual boundary for this. So this is building virtual boundary around this one. Now after building the virtual boundary, we'll be applying convolution. So this is the matrix used for convolution, and basically convolution is used to calculate the number of different behavior amongst the neighborhood. So as shown here, so this matrix is multiplied, the original market is multiplied with the convolution market, and the results are, this is showing the number of buyers around the market participant 1 -1. So the number of buyers are 3, as there are total 3 negative ones. Number of sellers are 3 for the same reason, and number of holders are 2, because there are only 2 market participants around it who are suggesting it to hold the share. Now working model simulation parameters, this is simulated in MATLAB R2012A. Dimension of the grid used is 50 by 50, that is 2500 market participants. Number of iterations 70 time steps. Number of buyers initially 289. Number of sellers are 1411. Number of holders are 800. So as we can see, we are considering the sellers to be in majority initially. So this is how the market looks like. -1, that is blue color in the center, are buyers. 0 for holders, that is green, is shown in the center. and it is surrounded by value